In this lesson, we're going to take a look at absolute value inequalities, what they look like, what they mean, and how to solve them. So the first thing, methods, what do these really mean? If I start with the absolute value of x being less than some value c, notice in this, the only thing that I have left or remaining on this side with my variable x is the absolute value itself. Now this could be an expression or just the variable. But if that is all that remains and is less than c, the way we interpret this out is that x is less than c and x is greater than the opposite of c. Or we could write this as negative c is less than x, which is less than c. So if our absolute value is less than, then we have an and situation. Think of this in terms of distance, because remember absolute value means distance from 0. We are less than c units away from 0. So if 0 was in the middle of my number line, I go out to negative c, and I go out to positive c, then I want what is in between those two values, so I'm closer than it. Whereas if I have the absolute value of x is greater than c, what this would mean is that x is greater than c, or x is less than negative c. So back to our number line, what I want is to be further away than c units from 0. So here's 0, here's my positive c, I want what's right of it. Here's negative c, I want what's left of it. I'm further out than that value. So how would we go about solving these when we have them? So our first situation here, the absolute value of x minus 4 is less than or equal to 15. So first question, do we have anything to simplify, distribute, like terms combine, or any variables of the same type to gather to one side? And in this one, the answer is no. So next, we do what our group tells us to. We're going to say x minus 4 is less than or equal to 15, and x minus 4 is greater than or equal to a negative 15. Now solve this. So I'm going to add 4 to each side of the first one. I have x is less than or equal to 19. Second one, I'm also going to add 4, and I'm left with x is greater than or equal to negative 11. So from a number line perspective, I have negative 11, I have positive 19, 0 is going to be somewhere around here, and I want filled in circles on both items, and I'm going for what is in between them. So this is going to be less than 15 units away from that value. And we'll talk about what that means here in a minute. Second one, the absolute value of m minus 16 is greater than 5. So a greater than inequality, absolute value inequality, we turn this into two parts that state or. So our first one is just what you see. M minus 16 is greater than 5. Or m minus 16 is less than negative 5. We change the direction of the sign and we change the sign of what's on the other side. So now we go through and solve. We'll start by adding 16 to each piece here. So m has to be greater than 21. Then come over, add 16 here. And I get m is less than 11. So if I get my number line out, I have 11 on here. I have 21 on here. Both of these will involve open circles because I'm not equal to. So the first one, m is greater than 21. That's going to be to the right. Second one, m is less than 11. That will be to the left. So if my absolute value is greater than a number, it splits and makes an or statement. If it's less than that number, it will come together and make an and statement. Let's take a look at some others. 2 times the absolute value of x plus 3 minus 6 is less than negative 2. So, we have to go through our solving process. First item, do I see any subtraction or addition? Yes, I'm going to add 6 to each side. So, 2 times the absolute value of x plus 3 has to be less than 4. Then, do I see any division or multiplication? The answer is yes. Multiplication, so I'm going to divide each side by 2. That leaves me with the absolute value of x plus 3 is less than 2. So now, what I need to do is break up my group. So, I'm going to write it exactly as I see it. X plus 3 is less than 2, and x plus 3 is greater than negative 2. I have this in its two different parts. My absolute value was less than, so it's an and situation. Now, subtract 3 from everything. Leaves me with x is less than negative 1 and x is greater than negative 5. So, getting out my number line, negative 5, negative 1. I want to be less than negative 1, greater than negative 5. So I get what's in between here with open circles on my points on the number line. Next, 3 times the absolute value of d plus 1 minus 7 has to be greater than or equal to a negative 1. So, first step, I see subtraction, so I'm going to add 7 to each piece. That leaves me with 3 times the absolute value of d plus 1 being greater than or equal to 6. Now, divide each piece by 3. That gives me the absolute value of d plus 1 has to be greater than or equal to 2. So, I have my absolute value isolated. Now I'm going to go through and break up the absolute value. I get d plus 1 is greater than or equal to 2, or d plus 1 is less than or equal to a negative 2. Since I do have absolute value being greater than, it becomes an or situation. Now I'm going to go through, subtract 1 from each piece, and that leaves me with d being greater than or equal to 1, or d being less than or equal to a negative 3. So, number line, negative 3, negative 2, negative 1, 0, positive 1. I have an open circle, a filled-in circle on each of my endpoints, and I want greater than 1 or less than negative 3. So we have all of our pieces from everything we've been learning in Algebra 1 so far thrown together into this one problem. Now, how would I ever apply stuff like this to make it more useful and meaningful in terms of everyday life? Let's take a look. When we were solving absolute value equations, I talked about something called a tolerance equation. The tolerance equation read this: the absolute value of our variable minus the middle was equal to the tolerance. Well, we can do the same thing with absolute value inequalities, just change our equation, our equal sign, into the appropriate inequality. So, in a situation, the weather forecast for a certain city on a certain day predicted a high temperature of 86 degrees Fahrenheit and a low temperature of 62 degrees Fahrenheit. Write an absolute value inequality to express this temperature range. Well, in order to do this, I need to have a variable. Since I am working with temperature, I'm going to pick my variable as T. Next, I need to have a middle right here. So what is the middle between 86 and 62? Well, the way to find the middle is to find its average, or its mean. So what I'm going to do is I'm going to take 86 plus 62, and divide it by 2, giving me a middle or an average temperature of 74 degrees Fahrenheit. So I'm going to have T minus 74 inside of my absolute value, and then the piece I need is tolerance. The tolerance is the distance from that middle to either endpoint. So if I were to pull out a number line, and I have 62 on here, which was the expected low, 74 for the middle, 86 for the high, how far is it from either the low temperature to that middle or from the middle to the high temperature? And we can look in both these cases, it is 12. So I have 12. Now we want what is inside of this range. And the way we get inside is less than or equal to. So the absolute value inequality that expresses this temperature range is the absolute value of T minus 74 has to be less than or equal to 12. And if we look back at some of the problems that we were working with, this piece in the middle here acts as our center. We always talk about absolute value being distance from 0. Well, if I have an equation or an inequality that says x minus 5, well, 5 now becomes my new middle, and this has to be less than or equal to 15. So I'm looking within 15 units of 5. 15 above, 15 below will satisfy the inequality. So this tolerance equation, absolute value inequality applications, really do explain more of our work. If you want, go back and take a look at the equations or inequalities that we had in this lesson and see this at work, but make sure you have this down and are ready to use it.